Hey, there we are. Okay. Good evening, everyone. This is Rich Ozer, and Gerald McKeegan is here with me. And once again, we are clouded out. Someday we're going to hit the trifecta. It's going to be warm, it's going to be clear, and it's going to be dark. But we don't have any of those conditions tonight. This is our eighth episode of the live telescope viewing from Chabot, and so far we've had one night that met the necessary conditions to actually hook up a camera to the telescope and show you what we're looking at. So tonight instead we have some announcements, and we'll talk a little bit about some prominent nebula that are visible from a home telescope or a good pair of binoculars, even here in the city. So, Gerald, I think you had some announcements you wanted to start with. Get your...
Yeah, just a couple of things I wanted to tell you about upcoming events. On June 30th, this coming, I believe it's Tuesday, or is it Wednesday? I guess it's Wednesday, is Asteroid Day. Each year, a large group of astronomers celebrate what we call Asteroid Day. There's various events that happen around the world to talk about asteroids and potential for asteroid impacts and so forth. And June 30th was selected because it is the anniversary date of the Tunguska impact. On June 30th of the year 1908, an asteroid came down over Tunguska, Russia. And it was about a 50-meter asteroid. It exploded in the sky about 40,000 feet above the surface. And fortunately, it was a sparsely populated area, mostly forest. It leveled several hundred miles or several hundred square miles of the forest, put on quite a show. It did not produce a crater because it exploded in the sky. But this is an example of what actually a relatively small asteroid can do. And because of that date and that anniversary, they decided to use it as the International Asteroid Day. So that's coming up. Also in July, on July 22nd, hopefully, the Mars 2020 Perseverance rover will launch from Cape Canaveral on its way to Mars. It will carry with it the Ingenuity helicopter, and they will make a 7-month trip to Mars, arriving on February 18th. So that's coming up right now. The launch date is July 22nd, but they've delayed it twice now. Original date was July 17th, and it got moved to July 20th, and just a couple of days ago, they moved it to July 22nd. So hopefully that's going to happen. It will be early in the morning. It's about 6:35 in the morning. But I believe that Chabot is thinking about doing a launch party for that event. So stay tuned for that.
Gerald, was that launch delay due to weather, or was it a mechanical issue?
It was an issue with some of the servicing equipment at the Cape. So it was nothing to do with the spacecraft, and, you know, the weather is this far out. Who knows what the weather is going to be like? But no, this was a delay because of some servicing equipment on the ground. It had nothing to do with the spacecraft or the weather. And then finally, I just wanted to let you know, you're going to see this on Chabot's schedule here pretty soon. But on July 31st, approximately a week after the launch, I'm going to be doing a presentation. We'll do a little space current events. And then I'm going to teach a lesson in orbital mechanics, no math or orbital mechanics, which ought to be a challenge. Talk a little bit about how they plan the flight path for Mars probes, and in particular, the Perseverance spacecraft. Explain a little bit of the orbital mechanics and show you why it takes so long to get to Mars. So stay tuned for that. And again, it's a no math presentation. It'll be a little bit of a challenge to do that without any math. So it'll be interesting to see how that works out. So those are some things that are coming up. Back to you, Richard.
Great. I can't wait for the orbital mechanics presentation. We may need to put together some clever video.
Yeah, right.
So All right, so for those of you who are joining us for the first time, I'm sitting here in front of Chabot's 36-inch research telescope, fondly named Nellie, and I'll move my camera up here so you get a sense of the scale of this instrument. This is a wonderful telescope. It's a wonderful telescope to hook a camera up to, and we had the what seemed like a good idea at the time to have regular Saturday night viewing live through the telescope using a DSLR camera. We're still hoping that as the weather changes throughout the summer that we'll have more opportunities to do that. But in the meantime, Gerald and I are putting together various programs on interesting events, current events to talk about in lieu of actual live viewing through the telescope. So that's Nellie, and maybe next week we'll have some better luck. Actually, there is 1 week where we're not doing the program, correct? That's
the July 4th.
Right, so on July 4th,
right.
we will not be having a program. So
we figured most of you would want to be doing something else that evening.
Yeah, undoubtedly. So anyway, what we're going to talk about tonight is some astronomical targets that are readily accessible to you from the city. If you have a small telescope or binoculars, or if you get out of town and have some type of astronomical telescope to view with, you can be looking at relatively nearby nebula. And in the springtime, we look at galaxies as amateur astronomers or astrophotographers because they tend to be passing through the most ideal part of the sky to take pictures or to do viewing. In the summertime, though, with the Milky Way so prominent in the sky and reaching a position and altitude in the sky that's ideal for viewing, we tend to look at closer objects that are inside the Milky Way and maybe 4,000 to 6,000 light years away instead of 40 million light years away. And so I picked out a few objects that are in the southern Milky Way. And if I'm going to share my screen here, and here we go. Okay, so summertime is good for the constellation Sagittarius, and Sagittarius rises in the southeast. Kind of, if you could see my cursor. Gerald, are you able to see the cursor on your screen? Okay, great. So it rises in the southeast and kind of makes this arc that you could see my cursor moving along the way, and then sets in the southwest. And so what you're looking at is really one of the farthest south constellations that you can comfortably view from the Bay Area. Because of course, all of the southern sky constellations are mainly invisible, but Sagittarius is right there on the border and makes for some nice viewing of nearby nebula. And again, when I say nearby, I'm talking 4,000 to 6,000 light years away, but that's really in our backyard. That means that within the history of civilization, if there is something noticeable or identified in those areas, we may even have a record of it, right? But it's at least a more understandable concept for people than something that's 40 million light years away or even farther. So that means the light that we're looking at is 4,000 years old or 5,000 years old or 6,000 years old, depending on the object. So the first one I wanted to talk about was M8. And M8, by the way, when there's an object named M something, it stands for Charles Messier, who was an astronomer in the 1700s who cataloged bright objects that he was able to see not far from Paris, and was one of the first astronomers to actually create a catalog of observable deep sky objects. And M8 is one of the prominent ones. And this is what it might look like through a large telescope. If you have one that is 10 inches or bigger, you'll see a lot of these details. You won't see the red color, but you'll certainly see the features. And it's called the Lagoon Nebula for the prominent dark curved band that is surrounding this bright area right here. And it's kind of got the, the shape of a lagoon. You can imagine this being the beach and this being the water. And of course, all of this is surrounding gas from the nebula. Of course, when you use the word nebula, you're really talking about a large ball of gas. And that's really what a nebula means. And there's many different kinds of nebula. And what's interesting about these prominent ones in Sagittarius is they tend to be star-forming regions. That means there was a whole lot of cold hydrogen gas that coalesced and formed new stars. And there's a perfect example of that right here. This very bright star that's in the middle of the lagoon, it's otherwise known as Herschel 36, is a star that formed inside a dark cloud of gas. And once it got hot enough, it blew away all the rest of the gas, revealing itself. Now, this is a massive star. It's about 9 times the diameter of our own sun and about 30 times the mass. So it's going to be burning very hot, and it's going to burn itself out much sooner than our sun will last through the billions of years it has left. So this particular star may only last 1 billion years, where ours will last for many more billions beyond that.
Yeah,
and that's because it's burning its fuel so quickly. Gerald, did you have something you wanted to say about this one?
Yeah, just that if it's 9 times the mass of our sun, it will actually last even less than 1 billion years. It might last only 500 million years. So as mass goes up, the lifespan goes down exponentially. So 1 billion years would be a stretch.
Yeah. All right, thanks. So anyway, this is a picture that was taken from the NOAO Aura consortium. And this is a consortium of large observatories, including the Cerro Tololo Observatory in Chile and the Gemini Observatory in Hawaii and the Kitt Peak Observatory in New Mexico. Here we go. And this is another picture of just part of the Lagoon Nebula, and this was taken by the Hubble Space Telescope. And you notice the color palette here is very different, right? So the Hubble uses many different filters to pick up different elements that are in the cloud of gas. And those filters, they're going to actually gather light in a spectrum that may look very different from what these colors appear as. So when they process the images, they assign colors to each of the filters. And for instance, the yellow might be sulfur, and the brown might be hydrogen, and the blue might be oxygen. And there's a standard palette that they decided upon with the Hubble Space Telescope to make it possible to compare one image to the next and know when you're looking at a Hubble image what those different elements are based on the color of the photograph or the colors that are in the photograph. So that's a Hubble image of the same object. And finally, I came across this image today from an astrophotographer named John Nemec. And it's John Nemchik. And this is a narrowband image. And what a narrowband image means is that you're using only filters to acquire the image, and you're other than visible light filters. You're not doing red, green, and blue like you would use for visible light. Instead, you're using special filters to pick up hydrogen alpha, oxygen 3, and usually sulfur being the third. And the blue here is all oxygen, and the red color in the borders of this cloud, which I know is very hard to see on Facebook, the red is all hydrogen, and the brown color is the red color was sulfur, and the brown color is hydrogen. And this particular palette was chosen by the astrophotographer, but what is most prominent here is the blue, which is all oxygen. And it kind of goes to show you how these molecular clouds that are forming stars contain many of the elements that we depend on in our own existence. And you'll find that oxygen is a huge component of molecular clouds and star forming regions, as well as a big component of nebula that are caused by a star reaching its end of life. So planetary nebula and other types of nebula due to the explosion or sloughing off of gas from an old star also contain a lot of oxygen.
Yeah, one thing though that we want to make sure everybody understands, although there is a lot of oxygen there, there is way more hydrogen.
Yeah.
But oxygen glows so much more brightly in ultraviolet that it just dominates the color, even though it's not the dominant gas in that cloud.
Right. Actually, the field of view here, by the way, is about twice the size of the moon. Right. So if you were to look at the moon and superimposed on this image, it would be filling up this center area here, but the overall image is about twice that diameter. So it's a fairly large object and it's fairly bright. You can see this with a decent pair of binoculars very easily. So next, we have M17. So M17 is right next to M8, and it's known as the Swan Nebula, and it's also known as the Omega Nebula. Take your choice. It either looks like a swan to you, or it looks like the Greek character Omega to you. It doesn't really look like either to me. Sometimes it looks a little bit like a swan, but I'll let you use your imagination. You can decide what it looks like. This first image, I guess, is more swan-like, where if you could imagine each of these bright areas, the one here on top and the one pointing downward, as being the wings of the swan, and possibly up here being the neck and head of the swan. This is an interesting photograph. It was actually taken by 3 completely separate telescopes, and the data combined to create this image. And the telescopes are the Sophia Telescope. That's an interesting telescope in and of itself, because it lives inside of an aircraft. And it's flown to a high altitude, and photographs are taken while it's in flight. The Spitzer Telescope, which is an infrared, mainly an infrared instrument, and the Herschel Telescope.
I got to tell you though, Richard, if that's a swan, it must be a swan that just got swallowed by an alligator.
Yeah, something like that.
I don't
right.
see the swan there.
Like I said, you have to use a lot of imagination on some of these objects and how they're named. But another photo of this, here we go. This is a pure Spitzer image, and the Spitzer telescope takes photos primarily in the infrared spectrum. So it's really able to pick up, especially more of the red hydrogen spectrum than other telescopes can, and it tends to favor that spectrum in its images. So you could see that the gas goes all the way out here to the very edges. Maybe you could see that on Facebook, maybe not. I see it on my screen, but I know that the quality diminishes as we broadcast through these various services. So we're able to see it pretty much all the way out to the edges of this photo. And again, the bright area is similar. If I go back an image here, you can see that bright area here is blue, and in the Spitzer image, they choose kind of a lime green for that same thing. And finally, a Hubble image. And the Hubble telescope has a much larger, longer focal length. and tends to be able to zoom in on very close specific regions of the overall object. And here you could see these kind of bulbs coming out of the nebula. And those are areas where stars are forming. So you've got this cold hydrogen gas, mainly hydrogen gas, and inside are stars that are starting to coalesce and starting to heat up. And they create, I don't know what you would call them, like almost pimples on the nebula, right? And eventually they'll heat up and blow that shell of gas out and become visible. There are some very famous Hubble photographs showing this phenomenon, some like the Eagle Nebula and others, but this is a great example of that same phenomenon happening in the Swan. All right, and next, M20 is the Trifid Nebula. And the Trifid Nebula is one of my favorite objects. It's a little dimmer to see, and but it's really got some beautiful detail. This is taken with a small telescope. This is just something I shot with an 11-inch telescope, and I'm showing you this one first because it gives you kind of an idea of what you might see with a home instrument going out to the country a little bit so you can get to some dark skies. If you were to look at this in the city, it would just kind of be a cloudy smudge, and you might see some of the dark bands in it. But if you leave the city, bring a telescope with you, you're able to pretty easily see these dark areas. And these dark areas are hydrogen clouds obscuring the lit up area behind it, right? So you could think of these dark bands as being foreground, and the red, pink, and blue areas being background. And I'm starting with that one because it gives you a good idea of the scale from a personal telescope. If you start moving into large telescopes, though, actually I'm going to go back again, concentrate on this region here where all of these lines intersect, and then this next photo is just that region, right? So this is from the Gemini telescope in Hawaii, and you can see just how much detail that telescope's able to pick up, especially in these dust clouds. And again, they have their own chosen palette that's unique to their instrument. And next, this is probably the best example of how the infrared spectrum differs from the visual spectrum. So going back to this Gemini image, you could see that these hydrogen cloud areas look like they're dark, no light at all coming from them, right? But the moment you look at infrared from the Spitzer, there's a lot going on here. They're not dark at all. It's telling you that there's a lot of energy coming off of those dark areas. And that's because there are stars being formed inside those clouds that are warming up the gas and emitting light in the infrared spectrum. I'll turn it over to Gerald here to see if he has anything to add to that.
Yeah, one comment. I got into a debate with somebody here about 6 months ago about the Trifid Nebula, which I call it the Trifid, and I notice you call it the Trifid. This individual insisted it's called the Trifid. So it's spelled Trifid. Take your pick. It's a cool nebula out there. Also, one of the things about a lot of that gas and dust out there is that it's relatively transparent to infrared. So not only does it glow because it's heated up by the stars within the clouds, but the infrared coming from stars behind the clouds is able to pass through the clouds. So that's one of the reasons why astronomers like to do things in infrared, is because the clouds tend not to be obscuring what's behind them.
Well, that's a good clarification. Thank you, Gerald. I'm going to go with Trifid. And the reason I'm going to go with Trifid is because of the 1950s B movie, Day of the Trifids. No one called it the Day of the Trifids. And so I think that pretty much is a decisive reason to call it the Trifid Nebula. And maybe that'll change a generation down, but I don't know about that. I don't know about that Trifid business.
That's our story, and we're sticking with it, right?
That's exactly right. That's about it for pictures tonight, but we can maybe answer some questions. Let me see what's going on here on Facebook. There's a lot of stuff going on here on Facebook.
Yeah, well, while I'm doing that, I want to make sure to mention, if you happen to be somewhere where it isn't foggy right now, around 11 o'clock or so, go outside, look to the southeast, and you'll see Jupiter and Saturn coming up. They're getting higher and higher in the sky each night. And so around 11 o'clock, 11:30 or so, you should be able to see both of them in the southeastern sky. Jupiter is the bright one. And to the left, about 2 fingers to the left of Jupiter is Saturn.
I do want to read a comment that one of our viewers made. I thought it was an excellent explanation. And this is from Madhur Malkani. And he says, when stars are born, they develop from large clouds of molecular gas. This means that they form in groups or clusters, since molecular clouds are composed of hundreds of solar masses of material. After the remnant gas is heated and blows away, the stars collect together by gravity. During the exchange of energy between the stars, some stars reach escape velocity from the protocluster and become runaway stars. The rest become gravitationally bound, meaning they will exist as a collection orbiting each other forever. And that's very true. And the stars that will originate from a cluster like this will likely form what's called an open cluster, right? Because the number of stars will be, anywhere from dozens to hundreds. And they won't be like globular clusters, which have hundreds of thousands of stars, which have a completely different life history. But from these types of nebula that I showed you tonight, undoubtedly we're looking at the precursor of an open cluster once the gas dissipates over time into deep space.
Right, and some of those stars, actually probably half of those stars, will be close enough together to where they form binary stars or even trinary stars. So they're orbiting around each other, and they stay that way. But the stars in an open cluster drift through space more or less together, but slowly drifting apart. So if they aren't in a binary, if you have 2 stars that are far enough apart in the cluster, they will eventually drift away from each other, because as they orbit around the galaxy, because the distance to the center of the galaxy is slightly different for different stars in the cluster, their orbital velocities are slightly different. And over periods of millions of years, that causes clusters to slowly break apart. So the binary stars will stay binaries, but the total cluster will slowly drift apart and eventually become separate stars. Our sun was born in what was once a cluster like that.
Okay. One person pointed out that these photos look computer animated, and you're kind of right, because one of the ironies of astrophotography and trying to shoot something that is very real and you want to show it to people as it appears is that there's a vast amount of processing that goes into making the image look like something worth viewing. And you have to reduce the noise, and you then have to bring out the contrast and stretch the light areas of the photograph so that they're amplified, and then assign a color palette to each of the, assign a color to each of the filters according to the palette that you want to use. So in a certain way of thinking, they are somewhat computer animated and generated. I guess that's different than when we used to use film for astrophotography. There was probably it was more of a natural process. You didn't have the opportunity to engage in the amplification and the noise reduction and all that. All you were really able to do was overdevelop the image and take very, very long exposures over multiple nights with the same frame, and hope that nothing got in the way or no one turned the lights on by mistake. So anyway, good comment. See what else we got. Is anyone into astrophotography on here? Yes, there's many people on here that are into astrophotography, and we'll probably have a program again one of these days, very specifically on astrophotography. Let's see. We don't want to get into telescope recommendations, but I do want to suggest that those who are looking to purchase a telescope or binoculars and want to learn more about the commercial equipment that's out there, join an astronomy club. I'm sure there's an astronomy club somewhere in your area, and usually the members of an astronomy club are more than happy to evangelize different types of equipment, and will give you opinions of what's the best to get started with. We tend to stay away from that ourselves here, but we can tell you that a great way to start in the hobby is with a good pair of binoculars, and then you can move your way up into a small telescope or a rig that is capable of doing photographs, if that's what you're interested in. Let's see. Here's an interesting question, Gerald. Is there an online presence for Chabot's shirts, gift shop, or any of that? Or we have to wait for the center to reopen?
There is no online. You cannot order online from the gift shop. They've talked about that in the past, but right now that capability doesn't exist.
Okay, thank you.
Sorry
about that. Yeah, it would be nice if that was available, but not at the moment. Let's see. Yeah, people have asked us this, would you be able to do a program on a random night when there's good weather? These tend to be announced in advance in order to get a good number of people to tune in. We'll consider that. I think it's a real possibility, but it's also hard on us personally on our schedules. I have a regular work week, and we do have a lot of things that we're busy with the rest of the week, and it's easier for us to kind of block this time every week to come up to Chabot and get set up. So it may be that we just have to kind of wait until our Saturday nights become more optimal for viewing again.
I think that's in September.
Yeah, that's right. That's hopefully this year. That's right. Alan put a word here. Is this a real word for these? When I was saying that there were these pimples of hydrogen gas that contain stars, he said the proper word for that is propylids. And I haven't heard that word before.
Well, I call them nipples, but you call them pimples.
All right, I don't feel so bad now. So maybe they're actually called propylids, and I'll let you all look that up to see whether it's a real word. If it is a real word, then I highly recommend it for Scrabble, because I think you get 3 points for a Y. I can't remember.
I don't know. I haven't played Scrabble in years.
Yeah, Alan is insisting that's the correct word. And thank you, Alan, because I'd never heard that before. All right, people seem to have had a good time, and I think we're going to call it quits. We managed to pull a 35-minute program out of a foggy night, and thank you all for coming, and we'll see you next time. We'll have something fun to look at then, whether or not the weather is good, and hopefully the weather will be good and we'll be able to hook up a camera again and show you something live. So take care.
Couple of last minute things here. First of all, next Friday night we will do what we call a moon mashup. We're coming up on full moon, and Chabot is going to do a moon mashup. We're going to show you photographs, tell moon stories, and have quite a few people involved in doing that. So something to look forward to. 8 o'clock next Friday night. And also, as always, please donate to Chabot. Go to the Chabot website and make those donations and encourage your friends and your companies and so on. While Chabot is shut down, it's been almost 4 months now. We are not making any money, and Chabot needs money to exist. So anything you can do to help out with donations, we'd really appreciate it. And with that, I think we'll say good night.